Alright, so this one is tricky, mainly because I didn't tell you how to do it. So there we go. This is going to be a learning experience. So hopefully a lot of us are checking out this video. So we said back in our momentum unit, we had two equations for momentum. We said, okay, we have this mass times velocity for momentum. And then we can say also that if we want to change that momentum, we apply some sort of force over some amount of time. And that is our equation for like the change in momentum of our object. So we can stand to reason that the same trend holds as it has been doing for our angular momentum. If we want to change the angular momentum, we don't force anymore, we torque, and then time is still the same. So our change in angular momentum is equal to our torque times our time, so how long we are torquing it for. So same exact equation, same exact format, but now we can be a little bit more comfortable doing this question. So what we need to do is we need to figure out the net torque, and then we know that it's happening for 2 seconds. So we can then figure out our total change in angular momentum. So really, let's just figure out these torques. So torque 1 is going to make our object rotate in the counterclockwise direction. So this is a positive torque. And we have force times the distance. So 200 times 0.5 is 100. This 100 newtons meters of torque. Then this force 2 is supplying a torque. It is also counterclockwise, so this torque 2 is also positive, and it is 100 times 1, because this is 0.5 and then 0.5 away, so just 100 newton meters. All right, and then now we're looking at torques that are making us go clockwise. So these are going to be negative torques. And we have, this is 0.75 away, or sorry, 1.5 meters away, and then 50 newtons. So 50 times 1.5 is 75. So we have negative 75 newton meters. And then our last one is going to be 2 meters away, and also negative. So negative 25 times 2 is going to be, what's that, negative 50? I should know how to do that. Negative 50. So our net torque is going to be 100 plus 100, so 200 minus 50 minus 75. So I believe that's 25, but I'm still going to do it on my calculator. No, it's 75. Good thing I did it on my calculator of positive torque. All right, and then we have this new idea that our change in angular momentum is our net torque times time. So we have a change in angular momentum of 75 times t is 2, because it tells us 2 seconds. 75 times 2 is 150, so our answer is A.